My name's Matt Perry, and I'm talking today about the path to a declaratively animated future. And the reason I'm talking to you about this is because I've been trying, sometimes fruitlessly, to simplify the creation of delightful animations and user interactions for about 4 years now. I started with the Pop Motion animation library. It's kind of a traditional animation library with the ability to constantly track velocity and pass that between input tracking and other animations to create like natural feeling animations that the user feels like they've had some input to. Its status as like an imperative animation library was never really a problem until I started trying to bring that into React. React's declarative nature often felt at odds with Pop Motion. It felt like we were taking things from two opposite approaches. And it really highlighted to me that Pop Motion was seeming to make quite complicated things simple, but at the same time, it wasn't really doing anything to make things, like simple things, any simpler. It just made them more complicated than they perhaps should have been. So 6 months ago, I released Pose. It's a declarative library that uses a CSS-like syntax. It tries to meld the simplicity of CSS with the power of JavaScript. But now I've got two different animation libraries with two very different approaches. One's imperative, one's declarative. And yet this talk is called The Path to a Declarative Animation Future. It's not to say imperative libraries have no place. I think they do. I just think they're going to be more useful for like our advanced use cases when we want a bit more freedom, perhaps, to do some things. But I think in the majority of cases going forward, a declarative API will make things a lot simpler than they currently are. And this is ostensibly about animation, but it's also kind of about how I took this imperative API and had to look at it from a different angle to make it declarative. So hopefully, if you've got no interest in animation, this has something for you as well. So the talk's in 3 parts. The first, I'll go through some of my issues with imperative animation. The second, I'll talk about the declarative and opinionated solution that I've come up with in Pose. And then finally, I'll talk about some of my ideas that I think this kind of API opens up in the future. Before I go on to that, I just want to take a couple moments to talk about the terms imperative and declarative. I think there's often a lot of confusion about the two terms. It seems to try at a React conference to talk about this, but whenever I've spoken to people, there seems to be confusion, largely mine. And I think it's because we're taught that these are two binary things. It's imperative on one side, declarative on the other. They're opposites, but I think the truth is somewhere a bit more of a gradient than that. We can probably talk about code as having more imperative or more declarative characteristics, where imperative code is really concerned with the hows. How is something made? It's often step-by-step logic, or it's concerned with wiring up different implementation details, whereas on the other hand, declarative code is quite descriptive. It's often an abstraction. The key characteristic of imperative code is that understanding what something is doing is the same thing as understanding how it's doing something. So if you want to make a meaningful contribution to an imperative code base, you really have to understand the nitty-gritty of like how everything's wired up before you can do that, whereas I don't think that's the case with declarative. As I say, code might be a mix between the two. React is a declarative library, but as I was saying before, Pop Motion's imperative, and so are many other animation libraries. So when we want to do things, for instance, there's this a component here. It's a element or a React Native view. It doesn't really matter. Well, it does because there's no mice on React Native. But anyway, this responds to hover events with a Spring animation. Spring animations are nice because they can maintain velocity between two different animations, end up creating quite natural and playful feeling interactions like this one. It's not appropriate for all animations, but I think for positional attributes like X, Y, scale, rotate, they seem to work really well. So how would we actually make this? Well, here's an example written in, well, it's not written yet, we'll go through it. It's written in React Animated, which is actually, if you've never used it before, part of React Native. Pose for React Native and the React Spring library both use this under the hood. So you might have been using this without even realizing it. At the top there, this is an animated sort of design implementation. We have to create a create animated component from our typical DOM button there. And then underneath, we've got our component that will turn into the Spring animation from before. So the first thing we need is a render function. And already you can see that we're really getting stuck into the weeds a little bit here. We're manually constructing our transition property. We're wiring up event listeners to manually fire animations. And to know what this is doing, apart from the naming convention that we've called it hoverable, which itself is a point of brittleness if we wanted to change the animation in some way. But we'd have to know that this, there's an on-mouse enter, on-mouse leave. OK, now we know that that's a hoverable animation. We need an animated value to track state and velocity. And then finally, we need to actually fire the animation itself. So there's a lot of stuff here, a lot of interleaving implementation stuff that's just kind of scattered around the component. And it's for a very simple effect. And it's so simple that it's deceptively simple. So you wouldn't feel bad if you sort of mix this into other code that perhaps doesn't have any relevance with it. And you mix it all up together, and it becomes harder to maintain. Its true imperative nature becomes clearer when we look at a few what-ifs. What if we wanted to animate a different value? What sort of places would we have to touch the code there? What if we wanted a different animation for enter and leave? And what if we wanted to add a new event like press or drag or something? How would those animations start to interact? This stuff is laborious to write and refactor. And because we're producing more code, our code ends up being more brittle. Now, here's an example of the same effect, but written in pop motion. Now, you don't really need to understand how this works if you've never used it before, but you can see between the two examples, you're only really trading in complexity. Before, we were concatenating a transform string, whereas now we're working directly with the DOM element reference. So the code's essentially hitting a lot of the same beats, a lot of the same notes. If I was to I'd ask politely for you all to go away and implement a Spring Hover component. Your code would probably also hit a very similar pattern. If you looked at all these with blurred eyes, they'd probably all look the same. To be fair, that's because I've taken one screenshot and copied it around the slide. But you understand the point. So with that in mind, just bear that in mind, this is a repeating pattern. Here's another classic sort of thing that we might want to do with our animations. Here we've got a sidebar that animates in and out. Once it's animated in, the children stagger in one after another. And likewise, on the way out, they stagger out, and then the sidebar animates out. I didn't implement this. I started also having flashbacks from the numerous attempts that I've made at doing this nicely. Without a library, I don't think you need a library really to take the way out of this one. You either have to do all of the animations in the parent, which would be my personal preference, but at that point, you start sending DOM references down, or maybe it's style attributes or whatever it is, animated values, depending on your library. Or you could split the animation across the two components with the child having a custom delay strategy based on its own index position or something like that. But that's a confusing mental model. It gives us a lot of messy code. Every strategy is ultimately doing the same thing. The code wouldn't look the same, but there's a pattern emerging. So somewhere in the stack, declarative APIs they're being interpreted and executed as a series of imperative steps at some point. So therefore, I think that the inverse is true. If we have a set of imperative steps or some disparate parts of imperative wiring, then we can identify patterns in that and then abstract them behind a more general declarative API. So before I go on to show you my attempt at fixing this, I just want to take a moment to say why I think it matters. Personally, I think the classic arguments in favor of animations have been won. There's been plenty of literature out there. I just wanted to offer a slightly different argument today, one rooted in culture and relevance. So at any given time, we're developing for a set of devices, and they each have a computational power. They have a certain fidelity of input and output. And as these capabilities increase over time, the quality of the native software that runs on them tends to increase with it. But these things aren't any easier in Swift or Java than they are in JavaScript. They use imperative patterns much the same way that we do. And you can tell whenever you get a new version of iOS, there'll always be a funny animation squirreled away that's broken, and you're not sure why they'd overlook it. But I personally think it's probably because they're using brittle paradigms as well. But they spend the time to make these animations because those devices have a cultural bar almost that other pieces of software have to live up to if they're to remain relevant on that platform. The web has its own culture and set of expectations, but uniquely it does play in the same arena as these native pieces of software. We have a continually deployed, minimum viable product, iterative industry, and creating animations often seems superfluous next to simply, does it work? The disparity in quality will only increase as our devices get ever more capable, but the web still seems like rooted in the past, unless we can change the culture, which I don't think is going to change unless we can make these things simpler to write, and if not free. And crucially, to not just to write, but to maintain and actually to delete as well. So if we can do that, that's a competitive advantage, not just as individual developers, but also as teams and companies and as an industry and a medium. So that's my argument against imperative animation in terms of React. So let's take a look at this Spring component from before. How can we make this simpler? Well, to find out how, we can take a look at how we'd implemented it with the world's most popular declarative animation library. So when not being universally embraced by the React community, CSS is actually like a fairly capable declarative animation library. Just imagine for a second that it did support Spring physics. What would our component from before actually look like? Well, it could look as simple as that. What is there to break there? It's easy to read and it's easy to understand. Now, obviously, some of the complexity has gone somewhere. It's gone to the CSS, which is nice because it's a place that is solely concerned with this stuff. It's solely concerned with the styles and the animations there. We know where we want to go when we want to add a new state, and it's very self-descripted. It is very declarative. Of course, CSS doesn't support Spring physics. That wouldn't actually work. It doesn't support any physics, input tracking, it doesn't support that. Staggering is just as much of a mess, if not more so than in JavaScript. Can't animate transforms individually, can't animate to and from auto, animate gradients, pass, blend animations, callbacks are broken, and the SVG transform model is such a form of widely recognized psychosis that I think there is actually a Latin name for that now. So what we want is something that combines the power of JavaScript with the simplicity of this CSS syntax. So that's kind of the approach that I'm attempting to take with Pose. Every component or element is described by an object. I actually developed most of the API just messing around on my phone, on the tube, just typing out my fantasy CSS, essentially. What if CSS was written with animations in mind first, rather than layout or styles? So we've got the Spring component from before. How would we describe this? Well, we could describe it like this. This is Pose's syntax. We've got two visual states, init and hover, scale 1, scale 1.2. And we're also saying it's hoverable, so this component will respond to hover events. We pass that config to a shamelessly stolen from styled components function called post button that creates a post component. I also called button here. And Ryan, I hope you're proud of me. You're on your phone, so no. But this talks a lot to what you were saying earlier with making these components a lot simpler. This looks just like the CSS example, but it's completely powered by JavaScript animation. If we wanted to iterate this, we wouldn't need to wire in new animated values, change transform props, or touch the DOM references, or make new animations. We'd just go to the one little place where it was all defined declaratively and change the properties there, which is quite robust and nice to use. This works great for what I've shown you. It would be this simple for UI events, because that's completely contained within the Pose syntax. But this sometimes we want to switch manually between one or more poses. We can do that with the pose attribute. That's pretty much as complicated as this gets. In here, we've got an isActive Boolean. If it's active, we fire an active pose. If it's not, we switch to an inactive pose. So we're concentrating all of the logic that we could possibly use for our animations in this one place. Before I go on to show you the sidebar example in Pose, I just want to take a moment to talk about opinions, because Before I said we could simplify imperative APIs by identifying patterns and using that to make an abstraction with a declarative API. I feel like we can actually do that once more. So by identifying patterns in the way a declarative API would be used, we can start making opinions on that. You've actually already seen 2 opinions in just a little bit of code that I showed you already. The first is individual transforms. So the transform property in CSS, Web Animations API, and even the style attribute transforms a single property where transform order matters. These 2 look fairly similar. Intuitively, these 2 things would end up in the same place in my mind. But actually, because well, we can show. So the first one would translate X first and then rotate. But the second one is going to end up in a different place because it's rotating first. And I would have thought the coordinate system would remain the same, but it actually rotates along with the element. So when we translate it, it goes off down like that. This is super powerful, but it's kind of a gotcha for new developers. I've struggled with it personally, and I also think that the one on the left is sort of more intuitive. The problem, these transform things are kind of laborious to write. They prevent using value default types, or they make it a little bit more complicated at least. And you can't animate these properties independently. But we can solve all that by taking an opinion. So in Pose, all of the transform properties are independent. So they're rotate and X. And I don't know if that's clear at the bottom there, but the opinion is that we always do translations first and then go on to do the things that will affect the coordinate system. But of course, if you're going to take a strong opinion like this, you kind of need to leave the override, the power in there a little bit. So you can actually animate between similar transforms, but you do forgive some of the simplicity. The second opinion was automatic transitions. I didn't actually define any animations in that example. I do this so often that people think that you can't do any animations in Pose at all that are your own, but you can. It's just that when you replace a lot of bitty imperative logic behind a declarative API, you have a lot more information than any one of those little bits could have alone. So you can start to take more informed opinions. So when going through the process of abstracting this API, I sort of asked myself, what information do we currently have at any given moment? And we have at least 2 pieces of information that I've used here to make this opinion. So the first is it's an animation library, which seems stupid, but it's something that CSS, it's a benefit that CSS doesn't have. So we can feel confident in making a transition default, because that will simplify things for a lot of people. But we don't want to do this blindly, so we have other information. You can make different, we know the different names of the properties, so we know if it's an X or Y, something positional that would feel great with a spring. But we also know if it's like opacity, which might make more sense with a linear tween. When you don't have to define transitions, this becomes fast to iterate, if not free. This is actually now faster, in a sense, than CSS. So let's take a look at our sidebar component from before. Speaking of opinions, like another opinion Pose takes is that if it finds 2 or more children, so sidebar here and item are both Pose components, they're children of each other. This nesting can go as deep as you like, but a parent-child relationship is declaratively inferred via the context API. So changes in the top flow down to the children. So obviously here, if item has visible or hidden poses, it will change to them. If it doesn't, it will just ignore them. So the way it works is that item now is completely oblivious to the way in which it's going to be orchestrated. It just has these visual states defined, again, hidden and visible. But sidebar, as the parent now, has control over this. And this can be, as I say, nested. So if item had children, it could start orchestrating its children. But it melds here some visual properties. So we've got X is 0 invisible and minus 100 off screen when it's hidden. But we've also got these other properties that we can use now, just stagger children. So when that's set to 50, that's 50 milliseconds. It will stagger them in one by one. But it won't do that because of before children. before children is true. So it says, animate me before you animate any of my children. So in a declarative way, we're like expressing how we want these components to behave. And there's no more wiring up of certain things. So this hasn't been an exhaustive overview of Pose's features, but I just wanted to concentrate more on specifically how we can simplify this imperative API with declarative code. So I just want to finish really by talking about the future of an API like this. This is middleware. It's stolen from Redux. It's the idea that you could globally apply a function, a transform function like this, that could take the configuration that's passed to any component, Pose component, and return a new one. So one way that I think this could be pretty powerful is if you could give it a function that had like a characteristic to it. So instead of allowing Pose to fill in the blanks when it doesn't see a transition property, you could describe your API, your interface with characteristics. So on the left, you've got playful, which might be really nice for like a children's website, or on the right, you've got like graceful, which would be good for like a wedding website or something like that. And by doing this, we can pass around sort of states and define them in the components, but then adjust their behavior on a global scale using this middleware. It might even be possible to sort of combine other middlewares that do different things. I think this has got a lot of potential for the future as well. Even on your own app, maybe you wanted it to have a thing, a certain characteristic or a feeling. You wouldn't be sharing these, but you could go to one place and affect the entire feeling of your app. So because we've now got a syntax that's completely abstracted from the underlying animation library, we could swap out the engine itself. So instead of using pop motion on the web, maybe when WebAssembly becomes more feature ready, I guess, we could swap out for WebAssembly. Maybe we make performance gains. Maybe there's some space savings. But it's the same with React animators. We could sort that out for React reanimated. No one would have to do anything. It would just happen, and we'd get performance benefits. And then finally, it's easy to imagine this kind of sidebar in a GUI like Framer or another one of these like editors. So this essentially is an input to a serialized object. So the path to outputting that as actual text that you can copy and paste into your app is like very easy to imagine, where all the hard work's sort of been done, and we can just pass these things through. So now as designers, you've got a much nicer, I mean you don't because it doesn't exist, but you would have a nicer handover experience to the developers. And likewise, if you're a developer who designs your animations in code, you could use a GUI like this to do the same job. It really closes down that feedback loop, and like I was saying earlier, just makes this iterative experience a lot cheaper for us to do. So we wouldn't feel so bad if a feature goes out with a lovely animation and then fails, and deleting it wouldn't have been a waste of time. So in conclusion, imperative APIs are great, they're powerful, but for the majority of use cases, we could probably simplify them, not just with animation, but animation too. To do so, we can look out for patterns and use declarative APIs to sum up almost these strands of imperative logic. Likewise, we can use patterns again to impose opinions. And finally, simplifying this stuff, simplifying animation and user interactions is really necessary, I think, to keep the web relevant in a time when we're pulling more and more software into our actual reality. Cross-reality devices are coming soon. I feel like this is the time not to slow down on this sort of stuff, but to make it easier and cheaper to keep doing it. So that was me. Thank you very much. That's my Twitter account. Yeah, thank you.